Hello, this is Tucker from the Math and Physics Resource Center at SVSU, and in this video we're going to go over how to take derivatives using the quotient rule. So the quotient rule comes into play when we've got two functions essentially divided by each other. So if you look at this example, we've got x squared divided by x minus 1. So basically anytime we've got one function of x divided by another function of x, we're going to be using the quotient rule. So if you look at the rule itself, we need four main pieces: g of x, f prime of x, f of x, and g prime of x, where the primes are just the derivatives of those functions. So in order to find each of those four pieces, f of x, g prime of x, and f prime of x, we're going to take each of these, the numerator and the denominator, and just assign them to each of the pieces that we need. So if we follow the rule, we've got f of x over g of x, so that makes these two pieces easy to find. So f of x is just the numerator, and g of x is just the denominator. Now, in order to find g prime of x and f prime of x, we're just going to have to derive each of these. So for g prime of x, x minus 1, we'll just find the derivative of each of these individually, remember. So the derivative of x, really x to the first, is just going to be 1 because of the power rule. And then 1, its derivative is 0 since it's a constant. So the derivative of g is just 1. And now the derivative of f, we're going to use the power rule again. So since we have x squared, this is going to give us 2x to the first, or just 2x. So now, since we have all four pieces that we need, we can just plug into the rule. So we end up with g of x, x minus 1, times f prime of x, the 2x, minus f of x, which is x squared, times g prime of x, 1. And then all of that is divided by g of x squared. So we'll have x minus 1, the quantity squared. So now, from here, we'll just have to simplify out. So we'll distribute here, and we get 2x squared minus 2x minus another x squared, all over, and I'm just going to leave that as x minus 1 squared, just for simplicity. So now we can combine like terms. So this x squared and the 2x squared will combine, which leaves us with just 1x squared minus 2x over that x minus 1 quantity squared. So this is the derivative of example 1. Now moving on to example 2, we're going to use the same process where we find each chunk. And then we'll just plug into the rule again. So f of x, once again, is just the numerator. So we'll have x cubed minus x, and then g of x is the denominator. So x squared plus 1. So now again, we have to find the derivatives of each of those chunks. So the derivative of f of x, we're going to use the power rule on both of these terms. So x to the third, using the power rule, is going to give us 3x squared, and then negative x will end up giving us just minus 1. And then for g of x, we'll do the same thing. So power rule on the x squared gives us 2x, and then 1, that derivative is just 0, so that leaves us with just 2x for g prime. So again, just plug into the formula. So we'll have g of x, x squared plus 1. Scroll down. Actually, no, we'll leave that for the formula. Times f prime, 3x squared minus 1, minus f, which is x cubed minus x, times g prime, 2x, all over g squared. So we have x squared plus 1, the quantity squared. And I'm just going to leave that denominator the same the whole time again. So once again, just distribute and simplify. So we'll FOIL this chunk out, and we get 3x to the fourth plus 3x squared minus x squared minus 1. And then we'll FOIL the other chunk out, and we get 2x to the fourth minus 2x squared. And then again, we're just leaving the denominator. So now we can combine like terms. So we'll combine those two, and we'll combine each of these x squared terms. So we'll end up with 1x to the fourth. All the x squared terms are going to go, actually no, I'm sorry. We have a minus a negative x squared, so we'll have plus 4x squared in the middle, minus 1, all over that stuff in the bottom still. And now this is the derivative of example 2. And that's about it. Thank you for watching.